Hello.
Good evening.
Good evening. Good evening, everybody. All right, let's get going, guys. Welcome to the session, and we're going to get started in just a quick minute. Lad, nice to see you. Pranati, Deliana, Hamza. All right, let's get going, guys, in just a quick minute. Um, let's see how we can work things out here. Um, So we're going to look at a few interesting topics today. Um, we're going to look at word problems. One of the most requested topics, right? Where you've got those wordy problems, and we will see if we can find some shortcuts, right? And other quick ways to solve it, right? So let's get going with it. Okay, so we'll start with the basic idea of solving with a variable here, right? So let's get started like this. Okay, okay, so let's see how we can start it. All right, lad. Um, okay, so how can we start this? Um, we are gonna, well, first let me introduce myself real quick. My name is Ash, and I am the founder of Blue Rocket Academy, right? So this is the 20-hour SAT math bootcamp, and today's topic is word problems. So maybe every like few days we have an instruction session, and today's topic is word problems. Last time we covered scatter plots, and next time we're going to cover percent. So we're kind of like moving in a cycle over here. Okay, we're kind of moving in a cycle, and we are round over here now. Once this is over, we continue here. So we continue moving round and round this circle, different problems every time. Okay, and most of the people here are in the boot camp. Hey, Lynn, and welcome to all of you who are here for the trial session. Okay, so let's get going with the most important word problem here, which is going to be solving with x. Okay, so let's see how we can solve this first problem itself right over here. Okay, so see if you can solve this first problem. It's 13. Okay, Nigel says 17. 17. Okay, so let's see what's going on here. There's a number such that 3 times the number. So all of this stuff is written over here, right? They're asking to find the number. So let the number be equal to x. Okay, that's important. And now there is a number such that 3 times this number, 3 times the x, right? So you just basically you're translating it to math here, translating the English to math. 3 times x here, so you get 3x minus 6. So 3x minus 6 is equal to, so you just replace it with equal to 45, right? That's super easy now. Welcome, Stefania. Lad, excellent. Pranati, very good. Okay, now you can easily solve it. You just add 6 to both sides, right? So this is gone. You get 3x is equal to 51 and x is equal to 17. And that's your answer, right? Yes, so be careful with this. Be super careful with what's going on. Okay, all right, so this is good. I think some of you just subtracted instead of adding. You might have subtracted and then you got the answer. Okay, so be careful. Let's try another problem here. For this one, no, not for this one, Pranati. So this one you might need to know a little bit more of the calculation, right? The tables, timetables. Okay, so let's try another problem here. Very similar type. Okay, let's try. Um, let's see how we can do another problem here. Why don't we try the same problem? There is a number such that 3 times the number minus 12, okay, is let's say 72. Okay, great. Very good. So you got x, very nice. Very nice, you're learning super fast. So 3x, so 3x minus 12 is equal to 72, right? And so 3x you add this time is 84. Super easy. After that, it's 84 divided by 3. And if you're having trouble with this, let me know. I'll give you some drills. Okay, 28. Very, very easy. Excellent job, guys. Okay, now let's see what else we can do here. Consecutive numbers are an important topic as well. They might ask you once in a while, right? What is consecutive number? At least you need to know what are consecutive numbers. So consecutive numbers means the numbers which are following each other, right? So if this is the first number is 10, the next number is going to be 10 plus 1, which is 11. Then the next number is 11 plus 1, which is 12. So let me ask you, if these three consecutive number integers you're asked this you're given this information, the integers are right consecutive, which means you're going to take well done penalty. So we're looking at this problem here. If the first number is x, right, the next number will be x plus 1, right? Just 1 more than x, right? And then the next number after that is x plus 2, right? And now they're saying, so something like 10, 10 plus 1, and 10 plus 2, right? Which gives you 10, 11, and 12. So now what they're saying is, what is the sum of the three consecutive integers, right? The sum of these three, which means you just sum this and this, right? Like this, x plus 1, x plus 2, summing it up. Now you can get rid of the brackets and just group the x's together, right? So you get 3x because you got x plus x plus x, that's 3x, right? And then 1, right? This should be a plus. 1 and 2, when you add it, you get 3. So 3x plus 3 is equal to 54, right? Yes, Pranati, that works as well. That works well. Okay, so 3x plus 3 is 54, right? And so 3x is equal to 51. And so x is equal to 51 over 3, which is 17. So that gives you your answer, right? So now let's see, how can you do the sum of, let's try this one. Okay, the sum of 4 numbers now. Okay, the sum of 4 numbers is equal to 66. So what are the numbers? So remember, the first number can be x, right? The next number will be x plus 1, x plus 2, and x plus 3. And the sum, you sum it up. Very good, Stefania. Excellent. Excellent job, lad. Right, so you just add these up. So you got x plus 1 plus x plus 2, right? Plus x plus 2 plus x plus 3. Very good, Devin. And that is equal to 66. Right, now you group these x's together. You've got 4 x's this time, right? So you're going to have 4x and then plus 1 plus 2 plus 3. That gives you plus 6 is equal to 66. Now you can solve this. Okay, so try to solve this equation. And if you're having trouble with solving this, just email me. I'll give you some drills to work on, so your calculation skills will get better. Okay, but all you do is you subtract 6, so this becomes 60, right? 4x is equal to 60, and so x is equal to 60 over 4, which is 15, right? And so the numbers are 15, which is x, then 15 plus 1, 16, and 17 and 18, and then you can see for yourself that, right, the answer works out. So Pranati, be careful. I don't know how you're getting a point. Okay, great. So okay, perfect. So that's how this works, right? Remember, the most important part is setting something equal to x, right? Let's try one more word problem now. This is also a word problem, but let's try this one. Let's try this one, number 10. Okay, this is a classic word problem. So you have to set something here to be equal to x, and the simplest thing that's you can set to be equal to x here is the cans of peaches. Okay, so set the cans of peaches to be equal to x here. I'm going to pull this to the whiteboard and then pull this problem on the whiteboard, and then we can talk about it. Okay. So she went shopping. She bought three times as many cans of tomatoes as cans of peaches, right? And too many cans of too many two times as many cans of tuna as cans of peaches. So let the cans of peaches be equal to X, right? How many ever peaches cans of peaches you got? That's X. So find the cans of tomatoes, right? Three times. That's the hint for you. And the cans of tuna, right? And then add them up, right? Very good, Stefania. Add them up, and the total is 24. Okay, so tomatoes is going to be, she bought three times as many, right? So remember, three times as many, which means it's going to be 3x here, 3x, because you already chose x to be the peaches, right? Right. That's why the tomatoes is 3x, and then the tuna is two times as many cans of tuna as peaches. So that's 2x, because this is twice of this and this is three times of it. And then you add them together, right? You add them together. Okay, so you get x plus 3x plus 2x, and that's equal to 24. Right? Hopefully that's making sense. Okay, so that could be a very standard problem, right? Remember, the most important skill over here is to understand what to be taken as x. If you took the tomato cans as x, then the peaches would be x over 3. It would be a confusing thing to do, right? Because then you have to work with fractions. That's why you take peaches to be x, tomatoes to be 3x, and tuna to be 2x, right? And then you add them, you get x plus 3x plus 2x, that's 6x. You group them together, add them, is equal to 24. X is equal to 24 over 6, which is equal to 4. And boom, that's 4 here, right? So I'm going to use a different ink. Okay, this is equal to 4. 3x, this is equal to 12. And 2x is equal to 8. And when you add them, right, 8 plus 20, 12 is 20, plus 4 is 24. So that's 24. Very good. Right? So Hamza, that's just the math language of how they say it. So 3 times as many means just 3 times. 3 times as many means just 3 times. Okay, so just 2 times as many means just 2 times. So you just need to work on these problems. Usually if you see 3 times, you can ignore this as many. You can say 3 times as many cans, right? So as of the peaches. Okay, hopefully that's clear to you. So I'm going to send this whole list of problems to you guys. I'm going to send this list of problems. You can try these problems and I can send you the solutions as well. But I think it'll be really good for you to try all of these problems, right? These problems are really great for you to understand the most important part, what value should you take as X? Everything is easy after that, okay? Great, Hamza, okay? So all right, so now this part we've done already. I'm just going to give you a shortcut for this, okay? Because this is not a linear equations section. This is more like a word problems. Try to understand overall what is the broad category of problems that are asked, like those long problems, right? Where hopefully we can get something done very fast. Okay, so the math is not important. The shortcut is important, right? So the shortcut here is, you are going to be, of course, you can read the problem. And by the way, this session is completely recorded. So the session is recorded, so you can watch it again, right? So the session is recorded and you can watch as much as you want. But here, the pediatrician, so you don't even need to read any of this information, okay? You don't need to read this. All you need to do is H is equal to 3A plus 28.6, right? It's got that plus 28.6 number, right? Which is the constant. And the 3A number here, this number here, and this number here, right? These are the two most important numbers in the linear equation. Okay. Yes, yeah, yes, Henry. So yeah, you can ignore the chat. You can even close the chat if you want. Um, so, so again, the shortcut is right over here, right? That they're asking you what is the estimated increase in the boy's height. So anytime you see something called increase, something by they're asking about the increase or the rate or even the decrease, right? The number in front of the variable is going to be the answer, which is 3. right? So that gives you 3 as the answer. Super easy. You don't even have to think much about it. Okay, that's your estimated increase, right? So let's see if you can understand, if you can solve this problem, right? Um, let's say you're given the height. Let's say you're given the height of another animal is 7a plus 4, right? And they're asking you, this is the age, this is the age, and this is the height. Okay, you don't have to think much about these problems. Okay, this is the height, this is the age. So what is the estimated increase? Right, super easy, don't have to think much, right? This is what saves you time. The estimated increase in height per year, don't forget that, per year. Okay, because this is a year, right? This is the year over here. So now they might ask, in like 2 years, how much does it increase? So per year, you know, it's 7. Perfect. And so you can just multiply 7 times 2 is 14, right? And that's your answer, right? Super easy to calculate these problems. So we're going to move on. The other shortcut is the estimated increase. The other shortcut is, let's say they ask you, what is the interpretation of this 4, right? The interpretation of this 4 is, it's the starting value, starting value, or it's also the beginning value. Okay, means the same thing, right? Or the value when this variable a is equal to 0, right? All of these mean the same thing. It's also the y-intercept, but in this case, when you interpret it, right, that's what the value is. Okay, so that value is your initial value. So here, if they ask you the interpretation of what is the value of 4, guys, if this is, you know, like the height of a horse or something, right? So the 4 means the beginning value, the starting value. And then you can think about it, oh yeah, the starting value means when the horse is born, right? When the horse is born, that's the it was how it was born with this particular height. Okay. Okay, so that's the interpretation of this. Let's see another quick one, and let's move on. Um, yeah, like this problem, for instance, and many of you, we have seen this problem, right? Super easy for most of you. You don't have to read anything here. Okay, when the time comes in the next few sessions, we're going to have a whole session on linear equations, but this is a very quick shortcut, right? And people who are already solving it, they've seen this stuff before. So right, so people who are new, so don't worry about it. You just need to look at this linear equation right over here, this linear equation, and they're asking you what is 331.4, right? Remember what I said, this number here, this constant here, is just a starting value, or the value when this t is equal to 0, right? And so you can easily see the speed of sound at t is equal to 0 is what 331.4 is. Okay, so one more time, I know this might be going a bit fast because this is a shortcut, right? Yes, when this is the value when this variable is 0, right? That's the basically that's the y-intercept, right? The y-intercept is the value when the x-intercept is 0. Here the x-intercept has a fancy variable name, it's the t, right? The temperature, that's the x variable, right? So when that is 0, all of this goes away. This 0.6 times 0, that goes away, and you get 331.4. So that's a shortcut. It might save you like 15 seconds. Just as soon as you see this word interpretation, it's either going to ask you to interpret this number or this number, right? This number is the increase or decrease the unit rate, and this number is the constant or the beginning value, right? Or the y-intercept. Again, it just y is equal to mx plus c, nothing fancy about it, but just the way they might twist a few things, right? So it's important. Okay, so that's so far we've done 2 types of word problems. We've done the one type of word problem where you say let x be equal to something, then you convert it, you translate it to algebra, and then you write down the equation, right, whatever it is, and then you solve it, and then you get the answer, right? That's the first type. The second type is this linear equation type, where they actually give you the equation. Okay, amount is equal to 400 plus 5x or whatever. Then they ask you to interpret this 400 or 500. So people who are already in the boot camp, I know this becomes easy for you, right, as you keep watching more and more sessions. But for the people who are new, right, or just started, or in the trial session, right, this is important. Okay, this is asked many times. You might have at least like one question, very high chance that they might ask you. So it's a high probability question. Now let's look at the next type of a question, which is ratios and rates. Ratios and rates. Okay, so ratios and rates, the problem is something like this. Let's say you've got 10 oranges. Okay, maybe not 10, 12 oranges. Okay, and the price of these oranges is, let's say 7, right? Some weird number. Okay, um, and so now you've got 12 oranges. The price of these, maybe we should make it simpler. Okay, 8. The price of 12 oranges is 8. So now they might ask you all kinds of weird things. Okay, they might ask you, what is the price of 18 oranges? Okay, so all you got to do here is super easy. 12 to 8, I'm just going to write down 12 over here, 8 over here, 18 over here, just the way I wrote it, and then x, right? And then all I do is put a bracket and then do this, right? So it's super easy, right? So you cross multiply now. Remember, the x is at the bottom, right? This is like how many dollars. So you cross multiply these, you get 12x is equal to 18 times 8 over here. Right? 12x is equal to 18 times 8. And then you can solve it, you can simplify it. This 12 can go down. And if you're having trouble with this calculation, just email me, even if you're in a trial session, and I'll help you out. Okay, so now you can do 6 times 2 is 12, 6 times 3 is 18, right? And 2 times 1 and 2 times 4. So you got 3 times 4 is equal to 12, right? Yes, that's exactly right. We are going to do that. We're going to do exactly that unit rate idea, Henry. So that's why it's rates right over here, right? We're going to talk exactly about that. So that's one way to think about it, right? So 12 oranges is $8. 8 oranges is how much? Okay. But before that, let's try to, yeah, why don't, so this part should be easy for most of you. Now, the exact same way, like you're saying, Henry, is the next way to do this is to find the unit rate, right? So same idea. Remember, this is the ratio style, right? This is the ratios way of solving the problem. Now we're going to look at the rates type of solving the problem, which is going to be 1 orange is how much? 1 orange is going to be, right? So 12, right? So 1 orange is how much? So, and then once you find 1 orange, right, everything becomes easy, right? So the 1 orange is going to be 8 divided by oranges, right? So 8 divided by 12. Okay, 8 divided by 12, right? Whatever this number is, right? And now you're going to multiply it by 18. Okay, whatever this number is, 8 divided by 12. Okay, so remember it's 8 divided by 12, right? So you get 0.67 over here, right? And then you are going to have, so this is the price of one orange is 0.67. Okay, 1 orange is 0.67, and then you can multiply it by 18 oranges, right? Super easy. 18 oranges times 0.67, right? And that gives you, so 0.67, because it's a round number, like you need to expand it a little bit more, right? It's going to give you, if you punch in the calculator, you're going to get something like 12. Okay, you just rounded it, but you can use an even rounded, more rounding, right, to get the correct answer. Okay, so that's going to give you 12. Now let's try the same idea on another concept, and let's move on. So let's try to solve a problem. Let's see if we can solve a problem over here. Okay, why don't we solve this kind of a problem here? Okay, so let's try to solve, now let's try to solve a more interesting problem. Yes, very good, Nigel. So I'll just change the problem a little bit here, right? Let's say you've got 40 bananas. Okay, and 40 bananas cost, let's say, C dollars. Okay, now you're asked, what is the cost of B bananas? Okay, so be super careful here. You're asked, what is X? Okay, similar idea. So you're going to write down 40 and C, and then you're going to write down B and X, right? I put the line here is equal to, and then you cross it. Let's see how many of you get it. Remember, you have to calculate the value of X here, right? So you cross multiply, you get 40X is equal to B times C, right? And then X, you just divide and you get BC over 40, right? Very good, right? That's how you're gonna solve this problem. Okay, and people who are in this boot, people who have just joined the boot camp, right? Feel free to answer, right? Feel free to answer. So most of the time, the first one is easy because it's a very robotic way of calculating things, right? They might give you something and you can just plug it in, just cross multiply and get the answer. Okay. But sometimes, especially when you've got these variables, right? So the left one is a bit easier. You just boom, 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 boom. You just write it down and you get it, right? Sometimes though, right? And that's why I'm showing you these two. Maybe like 10 to 15% of the time, this other method will be useful. So just at least for our understanding, guys, 40 bananas cost $C, right? So let's find the value of one banana. So I'm just waiting for someone to tell me what would be the cost of one banana. That's the unit rate, right? So one banana is going to be equal, right? Um, so be careful. Is it C over 40 or 40 over C? Right? So be careful. It's going to be C over 40, right? It's going to be C over 40, right? That's the cost of one banana, right? That's the cost of one banana, right? Now, because you've got C dollars for 40 bananas, so C dollars for 40, so you, 1 over C over 40 is going to be giving you the cost of one banana. One banana costs C over 40, right? This would be so easy if instead of C you had like, let's say you had like $80. So can you now easily see the cost of one banana? Oh yeah, it's so obvious. It's $2, right? 40 bananas cost 8. So intuitively you know it, right? But when you come to algebra, you might be confused, right? So it's 80 over 40, but 80 is C, right? So yeah, it's a ripoff. Yes. So C over 40, right? so so one banana is C over 40, right? That's dollars. Now, so how much do B bananas cost? So B bananas cost. That's easy. You're going to take C over 40 times B, right? And that again gives you BC over 40 because C times B is BC. So that's, these answers are the same. Of course, they're gonna got to be the same. So no magic there, but just remember there's two ways of doing it. And like Henry said, this is a more preferred way to do it. But of course, if you can immediately see, oh, I can do it the other way, yes, for sure. Go ahead and try that. Okay, so this is another, so this is the third type of the problem. Again, remember the let something be equal to X, then we did the linear equations, then we did the ratios rates, right? And these problems, there are more rates and ratios problems which are not so much so word related, right? There will be some other problems that we're going to have a whole section on them. Okay, it's a very important section. So rates and ratios is a whole complete chapter by itself. Okay, the pieces that I'm taking out of these are just the word type, the long word problems. Again, linear equations has its own section. Long problems are being covered right now, the shortcuts to these long problems, right? The actual theory, how things work out, we're going to look at in this chapter anyway, later on. Okay. So far we've covered the three most important types. Now let's try percents as well. Okay. Actually, why don't we try some rates problems, some extra rates problems? Okay, over here. Let's try. I think this is good. Let's try this problem. Okay, this is like a pure, unnecessarily confusing problem here. So this is non-calculator, but this one is, it's just take it easy and solve it, right? You can even put in numbers and see. Okay, so okay, a carpenter lays X bricks per hour for Y hours. Okay, so try to understand how many bricks he lays in this much time, and then X over 2 bricks per hour for 2Y more hours. So find out the number of bricks here, right? And then find out the number of bricks here, okay? And then add them together. So remember, X bricks per hour, right? That's the rate that's given to you, right? In 1 hour, you're laying X bricks. 1 hour, you're laying X bricks. So in Y hours, you're laying XY bricks. Okay, Y hour, you're laying XY bricks. Okay, so remember the first condition over here is X bricks per hour for Y hours. Okay, So it's going to be x times y. Hopefully that's clear to you. Okay. Yes, very good, Hamza. That's a great idea. Plug in 1 for x, right? So what do you get when you plug in 1 for x and 2 for y? So you get here, you're going to get 1 brick per hour for 2 hours. So you get 1 times 2, right? Which is x times y, right? Now, what do you get over here? X over 2 bricks for 2 more hours. So for x over 2 for 1 hour, right? And 2y more hours, right? So you're going to have x over 2 times 2y. Okay, this could be confusing for some of you. X over 2 times 2y. There's no magic here. It just x over 2 bricks per hour, and there are 2y more hours, right? So you have 2y more hours, so this 2 and 2 cancels out. Okay, and so you're left with just xy. So you've got xy here from this guy, and you got xy here from this guy, and then you just add them to get 2xy. Okay, so that's how easy it can get, right? So remember, it's just numbers. If I told you this was 1 like Hamza and like 2, this would be so easy. 1 times 2, and then this would be half a brick per hour for 4 more hours, right? And then you would do it, oh, I get 2 again, because half times 4 is 2 again, right? So 2 plus 2 would be to get the same value. Okay, so let's try another problem of this type. And again, this session is recorded, guys. For people who are just starting out, it might be too fast. It most definitely will be too fast for some of you. So take it easy because the session is recorded. And once you, if you want to join the bootcamp, right, it's going to be, then things become easier, right? Your brain gets right, it gets used to the speed. Okay, so here instead of x bricks, I'm going to say, why don't I actually put it over here? A carpenter lays 2a bricks per day, okay, for let's say 15 days. Not 15 days, my bad. 15D days. 15D days, okay? And then he also lays A over 3 bricks per day for, let me see, 24D days. That's crazy, okay? So now try to find out how many total bricks you've got. So find out how many bricks totally you've got. Remember, 2A bricks for 1 day, and there's 15D. So find out what the answer is over here. Find out what the value is going to be over here, and add them together. Okay, let's see how many of you can get this. 2A bricks. Very good, lad. Very nice. That is indeed the answer. So remember, 2A bricks per day for 15D days, right? So that's the unit rate. This is your unit rate. So some of you were asking, like, which one should you use? This is the time when you use your unit rate. 2A bricks for 15 days, which means you multiply by 15. Don't forget the D here, right? So 2 times 15 is 30 AD, right? This is not an easy problem. So if you're just starting out with algebra, right, this could be a bit complicated, but today is like a word problem section, right? So it's a consolidation of what we've done before, right? And here you're gonna get A over 3 times 24. So try to solve try to simplify this now. Yes, yes, Stefania. Yes, it'll be given to you. I've just not included it over here. Okay, but yes, that'll be an answer choice. Okay, so you cancel this, you get this over here, then you get 8AD. Okay, and then you got 38. You just need to add them and you get this. So this is not an easy question, but this is how easy things can get. Because, right, let's say somebody told you instead of this problem, like I'll show you how easy this problem is once you get this understanding, right? Let's say you have this problem right over here. I just copied this over here, right? And instead of 2A, if somebody were to tell you, same problem, right? Exact same problem. Instead of this, somebody were to tell you 10 bricks per day for, let's say, 30 days, right? So it's easy for you to think about it. 10 times 30, right? That's 300. But that's exactly what's going on over here, right? And then you're told like whatever, like 40 bricks per day for 48 days. Easy, 40 times 48, and then you add it. That's all you're doing here. Okay, so not much. It's just numbers. I've seen before when people encounter variables, they might think, wow, what's going on? Is this something special? It's nothing. It's just a number. Okay. Um, so I think this was good. Let's see what else we can do. Okay, so I'm going to give you a quick shortcut. Okay, again, we've covered this. Wow, some people are actually solving it. Excellent. So you solved the previous one as well. Good job. um, Now let's look at percents. Okay, let's look at the top problems that are asked for percents. So I'm going to give you a shortcut. I'm not going to explain it. The explanation is going to come actually on Monday when we do the real percents and exponents problems. Okay, but these percents problems are just so important for everybody to understand. Okay, so here's a percents problem. Let's say you've got a bag. Okay, let's say its price goes up, and let's say it goes up by 15%. So anytime I see a percents problem, I always first never even look at the price of the bag. I only look at the percent and I figure out it's going up, right? Exactly right, guys. So now, if it's going up, what you need to do is, let's say this is, let's say 700 and 700 over here. So the new price here, this is the new price. Okay, all I do is I take the 700 multiplied by 1.15. Why do I take 1.15? Because there's a 15% here. So 1 plus 0.15, right? Remember what we're doing here. You take 1 plus this value here, so 0.15 like this. Okay, and that's going to be your new price immediately. Okay, immediate answer. Don't try to multiply this with this and then add it. It's very confusing for the reason I'm going to tell you very soon. Okay, this is going to give you your new price. Okay, that's your new price. Okay, looks like it's 805 because you take 1.15 times 700, that gives you 805. Right, that's good. All set. Now, this is not what the SATs are going to ask. They never ask these type of problems. Okay, what they will ask you is the other type of a problem. Is the same deal. You're given 700 before and you're asked this, right? Now they're actually going to give you this price. Let's say they give you a price of like 900 and 920. Yeah, they'll ask you very, very rarely, Daliana. Okay, most of the time they're going to ask you this type because they want to confuse you. Okay, so the old price. Okay, what's the old price? Okay, what's the old price here? So remember, you cannot do 920 times 1 minus 0.15. Okay, that's wrong. Okay, what you should do is exactly right, Lynn. Yes. So old, right? So old times 1.15 is 920, right? So now you need the old is going to be 920 divided by 1.15. Okay. Yes, Nigel. So perfect. Now you know it, Nigel. I'm super happy. My work here is done. Right. I'm super happy. Many people have said that before. I used to do that, but I don't. So great. So very happy. Now you got it. Right. So now that therefore 920 divided by 1.15, right? You get this answer. And then you're done. Okay, so very, very, very important part. Okay, they might give you like 4 or 5 lines. The actual problem to be solved is just this. Okay, they'll give you like a big story about someone. The actual problem is just as much. Okay, how to solve this problem will come up in the next session on Monday, right, where we are going to talk about the various ideas. Okay, not only that, for percent problems, right, and again we're going to explain this in more detail, but right now suppose it goes up by 15%, then it goes up by 10%, right? And then it goes up by 20%. Think about how complicated this problem has become now. Okay. Now, let's say the price is 600, right? And they ask you this, they might ask you, right? This price. What is this price? Super easy. You do the same thing. 600, multiply it by this multiple now, which is going to be 1.15 multiplied by, wow, people in my boot camp are shining. Nice, super happy. Okay, this, and then multiplied by 1.20, right? That's the answer. So the goal is, as soon as you see this problem, you should be able to solve it in like 15 to 20 to 30 seconds, right? Otherwise, what you might do is like you'll use those other methods where you're expected to show the work to your teacher and you'll spend a lot of time. Yes, Henry, all the time. Anytime they ask you these types of problems, they're going to ask, you'll be getting a calculator. Okay, so no worries about that. Okay, so that's the answer, and looks like the answer is 910 point odds, right? So you multiply this and you get your answer. Now the still more complicated problem, and this is the last one we're going to do of this type, is they are, right, they might not give you this, okay? They might give you this one here, okay? They might give you 800 and let's say this comes to 920. And they might ask you, what is this? The old price. So you use the same deal, right? Old times 1.15 times 1.10 times 1.20 is equal to 920. Same deal, right? But now you know how. All right, Len. So all the same deal, right? So what you need to do is you take this value here, right? Multiply this, whatever it is you get, right? Move it down, right? So it looks like some people have gotten this answer 1.518, right? So now you get all times 1.518 is equal to 920, right? So the old is going to be 920 divided by 1.518, and that's going to be your answer, right? So it looks like the answer is 606-ish, right? 606. Okay, so very good. So see, I'm going to wait for some of you to solve this problem. I'm going to give you another problem, okay, to solve. Okay, so let's try to solve this problem, okay? And then let's move on to something else here on percents, and then maybe let me see what else we can do here. Okay, so let's see. So what's the deal here? Let's say you've got, so we're gonna solve the actual SAT style, okay? So you are given that this new price of the bag is, let's say, 750, okay? And the price you're told was increased, it was increased by 25%. Okay, so find what is this old price. So remember, you gotta take old times 1.25 is equal to, and I'm gonna leave it with you. Let's see how many of you can get it. And people who are who are new, right? Please join, please participate. I think that's going to be helpful. Okay, so well done, Nigel, Stefania, Deliana, Hamza, Lynn, Devin, Pranati, Henry. Very good. Okay, so again, all you've got to do is you take this to be 750, right? Remember, these are some very standard SAT problems, okay? And then the old is equal to 750 divided by 1.25, right? 750 divided by 1.25 is exactly 600, and that's your answer, okay? That's your answer, right? You can also check it, 600 times 1.25, right? Using the other method, it's got to give you 750, and that's your answer. If you do 750 times 1 minus 0.25, that gives you a very strange answer, okay? That's wrong, okay? That answer is some weird number, 75 times 0.75. That gives you 562.5. That is wrong, okay? Don't do it this way, all right? That's not correct. I'm telling this to you time and again because I know many people like to do it this way. They just visualize it going down this way. That's wrong, okay? This is good. Now let's move on. Yes, if it's saying it's going down, that's when you subtract. Exactly right, Pranti. So, and I think you should definitely draw it. I exactly totally agree with what Pranati you're saying, and Hamza as well. Very good. So if it's going up, draw this up. If it's going down, draw down. Okay, it takes you less than like 5 seconds to draw it real quick. Okay, down, up, down, and then you can see what's going on. Okay. So we're going to talk in the percents problem further. Like this, there's a whole section we're going to talk about percents and exponents that's coming on Friday on more complicated problems, right? Like what happens if the price goes down, then there's a sales tax, it goes up again. What's going on with those type of problems, right? But for now, what we are going to do is very good, Nigel. So you already draw it. Excellent. Excellent job. So now what we're going to do is we're going to look at a concept of an extension of percents, okay, which are called exponential models. Okay, we're going to talk about these exponential models here. So what's the deal with this, right? So think about it like this, and this is again an important part. Okay, you've probably seen this problem before. Okay, let's say you've got some money. Let's say you've got 10,000 bucks, $10,000. Okay, let's say that goes up by at the rate of 5%. So that's just your interest rate. This is just your interest rate. Then it goes up by 5% again. Okay, and then it goes up by 5% again. So remember what you've done before to get the new price, right? You've taken 10,000, which is your initial price, and multiplied by 1.05, which is this guy, multiplied by 1.05, which is this guy, and then multiplied by 1.05, right? So now, if these are the same, right, there's no need to write it this way. You can just write it as 10,000 times 1.05 to the third power. This is how many time units you've got, right, which is 3 units, right? Great. So let me see what you get here. 105 to the third power times 10,000, right? You get 11,576.25, right? Very nice, very nice, very nice. Okay. So again, people who are just joining the bootcamp, right, or people who are just in the trial session, feel free to participate, because I think participation, right, that's the whole idea. Otherwise, you're just on YouTube and like watching these videos, and then you go to sleep, and then in the morning after 2 days you forget. Wow, what was that? It was a cool trick, but I forgot what to do, and then all your time is wasted and you don't get a great score. So participate. The more you participate, right, the more it sticks in your brain for longer. Okay, it sticks in your brain longer for sure. Okay, so this is good. So now let's try to calculate this answer. Suppose you've got 25,000 now. Okay, got richer, right? And let's say you put your money in the bank, and it's going up by at the rate of 7% for 5 years. So can you please tell me what's the price going to be after 5 years? Very good. Some people are super fast. Okay, multiplied by 1.07 to the fifth power. Okay, 1.07 to the fifth power. I always calculate this part first, right? Then I kind of like have it in the calculator, 140255. It's already in here, and then multiplied by 25,000, right? Multiplied by 25,000, then I get 35063.79, etc. Right? So try to calculate this first, and then everything becomes easier. I calculate this, then I multiply it by this. Okay, but either way, whatever works for you. Okay, what happens if it's after t years? It's going to be t over here. Super easy, nothing, no change. Okay, that's it. Okay, so this is how the price goes up. Now let's actually try to solve a problem, and we've seen this problem before. Let's see if we can find it here. Okay. So let's see what we can do with this problem. Yes, Pranati, exactly right. If it's remaining the same, you're going to have that t. Otherwise, you need to have separate numbers. Okay. Okay. So very good. I think you guys already got it. Um, but for the people who are new, right, they might want to try this problem again. So I'm just going to explain this one more time. She opens a bank account that earns 2% interest compounded annually, right? Her initial deposit was $100. So that's your initial deposit, right? 100, like we said. And then it's going up by 2% every time. So this is 2%, 2%, 2%, right? So you're going to have 100 times 1.02 times 1.02, etc. Or you can raise it to the number of years, and this is t years, right? So that's your formula right over here. Now you compare it with this, right? So the way they've given it is 100 x to the t, and they're just asking you this silly thing, this x, and what is this x, right? They are the same. So x is equal to 1.02. I'm not doing it 3 times. I'm just showing you that it can go on, right? I'm just giving you an example, right? So it can continue going on for how many ever years. You don't know how many years it is. It's for t years. So I'm just showing you how it looks. So it could go even the fourth year or the fifth year, right? So it continues going on. So hopefully that's clear to you, Henry. Okay. So this is great. Now let's take a look at the next problem here. Okay, this problem is good. Let's see what happens for this problem. Okay, so, and again, some of you have solved this. but let's try to solve it again with a slightly different set of numbers. Okay, so I think you've solved this before, so I'll leave this with you to solve this particular problem, but I'm going to change the numbers on this. Okay, so you get more practice. Okay, so Jessica's friend Tashan found an account that earns not 2.5%. Okay, he earns 3%. Okay, compounded annually. So he made an initial deposit of 100 into this account. Okay, and Jessica made the same amount. So Tishan and Jessica, they're starting at the same value, right? Now, after 10 years, how much more does Tishan's initial deposit? So this is Tishan and this is Jessica, right? So Toshan, after 10 years, is going to be 1.03 to the 10th power. And Jessica, as you already know, is 1.02 to the 10th power. So now see if you can solve the problem, take the difference, and let me know what the answer is. Remember, though, the SAT can be very tricky sometimes. Round your answer to the nearest cent. Okay? It's very important to find the correct cent, which means you need 2 digits and round it correctly. So 1.03, I'm going to solve the first one to the 10th power is going to give me 1.3439, right? So I multiply it by 100. And I get 134.3916. Okay. And then this one over here is 1.02 to the 10 power. That's 1.21899 multiplied by 100. You get 121.8994. Right now, take the difference between them. So you got, I usually take like 4 digits for these kind of crazy problems. So there's never a doubt in my mind. 8994, right? Right? And then you do 134.3916 minus 121.8994, right? That gives you 12.4922, right? This is still a slightly rounded number, but it's easy for me. So these are gone because it's 2 digits, and that gives you your answer, right? So 12.49, very nice. Most of you got it. Okay, very good. Okay, so I know this is not an easy problem. Look, this is problem number 38, right? So this is the last problem. So 1.02, yes, you're right. So Jessica opens a bank account that earns 2% annual. So right over here. Okay, so it's a continuation of the last problem. Yes, it was connected. You're right. I didn't mention that, but yeah, it was connected. So 2% is right over here for Jessica. Okay. Okay, let's look at the next problem. So once again, let me also tell people what's going on here, right? Yeah, last two are kind of connected sometimes. Okay, so guys, for people in my bootcamp, just give me 2 minutes. I'll explain what's the bootcamp about for the people who are new here, right? So just give me 2 minutes. So there's a 20-hour boot camp, right? We are doing word problems right now. We're going to go to percents, and then we go to rates, ratios, and we keep going on to each of these. In between this, we sometimes do some reading sessions. Sometimes we do test taking, like last week we did test taking, right? So we have these 10 important topics, and in between these, I give you these practice problems to work on, so you can solve these practice problems and you can get the answers. And it's important for you because these are all collected from the past tests. Okay, so all of this material, right, plus some more is you can join the bootcamp, and all of this is for our all-time one-time fee of $95. Okay, I'm gonna give you the link right now. Um, okay, once you log in over here, once you you join, you can enroll the session. It's just for 95 bucks, one-time fee. So even after let's say you did your 20 hours with me, right? And if you say, hey Ash, I want to join one more time because I'm taking the test in March again, right? Yeah, sure, feel free to join. There's no extra fee. Okay, so it's only a one-time fee for every single thing. So in that, right? Yes, Hamza. Right. So you get these practice problems. There's 10 such practice sets, right? For instance, there's this percent sets, right? Which we're going to do next time. Then there's also this quiz which improves your speed. So let me show you this particular set of problems that we're going to do on Monday here. Okay, so give me 1 second. This sheet is a bit big because I've collected all of these problems together. So all of these problems, you're going to understand all the shortcuts to work on all of these, right? And so you get all of these, and plus you get this kind of a quiz, right? You get this quiz, it's only 45 seconds, and you have to solve it super fast. Like this is exactly something similar which we did today, right? So you get the hint here, you can solve the problems, right? And you can right, this definitely helps. I've seen so many people score improve just using this. Okay, so it's very important for you to very good, Deliana. So right, nicely done, Franti. So all of these, all of this material, right, you can get if you just are able to solve these problems, right? This is again like for instance something like this. Okay, this one is a bit too much, but let's say and you can always reset it, try 20 minutes, right? Easy, like this kind of a problem, right? All of these problems are included. There's also other quizzes which are specifically meant for percents and linear equations because those are very important topics. So I've got other quizzes as well. Okay, so all of these problems are in this. By the way, we're going to check on Monday how to solve this one. Okay, yes, yes, it's, and you can check the answer over here, right? So be careful, you get 3/2 over here. Okay, so perfect, very good. So all of this is going to help you. So remember, you need to work on watch the videos, do the practice problems, do the timed quiz, and then after that is done, you take the full test and see if your score doesn't improve, right? Your score's definitely got to improve, right? All of this material I'm showing you, it's occurred again and again and again in the problems, in the practice tests and in the real tests. Definite improvement in your score, right? So with that, let's move on to the next problem. Yeah, every week I get someone or the other saying their score improved by like at least 100 points. um, so let's look at another problem of this type. This is, by the way, a good challenge problem for some of you. Okay, so this is challenge, this is a good challenge problem. I'm going to give you the sheet anyway. You're going to get the recording and the sheet, so work on this problem. It's a great problem to think about. Okay, let's now try to think about saline solution. There's a problem. If you want to understand how to solve the saline solution, we've solved it before, right? Some people had asked it. We've solved this problem to death, like very easy answer to get this kind of a saline solution. Okay, gear problem, we've solved it. So if you want to understand how to solve these problems, just email me. I've solved them somewhere, and I'll give them to you. Okay. Okay, so let's see what other problem we can solve here. Okay, sometimes, so we are just looking at all of these word problems, right? That are occurring again and again in the test. Okay, so another type of a word problem is some kind of like um, this type of a problem. Okay, so let's see how you solve this type of a problem. So very long problem, right? You don't really need to even read this problem. That's the whole idea about word problems. The word problems are problems which should be reduced to problems where the words are not needed, right? You should just identify it with your eyes. And how do you identify what this problem is? Well done, Devin. Okay, how do you identify what this problem is? Oops, sorry. You're going to identify what kind of a problem this is by looking at this, okay, by looking at the answers, right? As soon as you look at the answers, you know, oh, I know I've studied with Ash. I know this is the system of equations, right? Once you know it, this is system of equations. So just think about it, okay, be in that system of equations mode of mind, and then you can easily solve this problem, right? So the easiest thing to do, first of all, is try to figure out, um, right? You can figure out whichever way you want, right? But you can try to say, first of all, B plus L is equal to 350. What is B and L, right? B is this bench seats and L is the lawn. And go and look for 350. Okay, so organizers of the concert allowed 350 tickets had been sold. And these are the two tickets. So B plus L is equal to 350. That's a clear winner, right? That works. So you can eliminate this choice immediately, right? Now, the next piece over here is you've got $75, okay? and the bench is $75. So you're going to have B times 75, right? Plus 40 times, sorry, plus 40 times L is equal to the total amount, right? The total amount is right over here, which is 19250, right? So you can easily, as soon as you see 75, right, you don't even need to solve anything else because there's a plus sign, so you can cancel this, and so you've got this answer immediately. Okay, but that's a good point, Lynn. B can be solved because what is this? What is this weird 1950, right? That maybe you divide something and you get it, but this 19250 is right over here, right? You can get this. I'm gonna show you one very easy way to think about it. Okay, this is a very, very standard problem. This will come in this will come in over here, system of equations. Okay, this is a whole session, discuss a whole hour a discussion on system of equations. But what this is, let's say you've got salads and burgers. Okay, that's my favorite, salads and burgers. Okay, let's say you've got S salads and B burgers. Okay, now they might tell you the total number of burgers and salads is, let's say, 1,000. So you're going to put 1,000 here. Salads plus burgers is 1,000. This equation, I call it the quantity equation. Okay, the quantity, how much is there, right? And now you're also told that the salad cost is, let's say, $7, and the burger cost is 10. Right? So what you do is you multiply these two and you get 7S. And then you multiply these two, you get 10B. You add them and whatever, they might give you the amount, right? They collected, like, let's say 5,000, right? So this is the second equation. This is, I call it the money equation or the cost equation. So there's always two equations. Usually there's going to be two equations whenever they have this kind of a problem, the quantity equation and the money equation. Okay. So remember here as well in this problem, right? In this problem as well, we had, where's the problem gone now? We had the quantity and the money equations, right? We had both of them. Okay, something slow here. Okay, so we had the quantity equation, which was the quantity of the tickets, right? This was a number of tickets. This was a weird thing, so we canceled it out. This was as well the number of tickets, and the next was the dollar, right? So therefore, you had something times something plus something times something is going to give you 1925, and that's why you got this. Remember, this is your dollar equation, and this is your quantity equation. That's usually so easy. Usually, these two equations, that's all you need for a system of equations whenever you've got a word problem. How do you solve it? What's the fastest way to solve it? What are the other questions that the SAT will ask you? Those are not word problems. That will be covered in the actual SAT system of equations session that we're going to probably have maybe next week, early next week. Okay. But before that, you just need to understand what these problems are. So this is how you can identify these types of problems, right? Now, again, this is another type of a problem where you just need an inequality over here, right? Same deal. Okay. All of these problems, I would encourage you to think about them and solve them, right? They're very, very similar to what we've done right now. Okay, so try to work on them. I'm going to give this sheet to you and see how you can solve it. Okay, for instance, some of the problems can be ridiculously easy. I'm going to show you this problem, for instance, how easy it can be to understand this problem. Okay, so let's first read this problem. So this is a visual problem, and that comes in the kind of like looking so the less than sign, so this sign, somebody's asking me less than sign, right? So that means y is less than 2x plus 5. So that's the less than sign, and this is the greater than sign. So we'll talk about it. Just email me, and then we'll discuss about the less and greater than signs for sure. Let me know, and I can give you some drills. By the way, I've also got some super drills here. Okay, for people who are having some difficulty with any particular, sometimes people have difficulty with inequalities or just fractions, right? All of these are in here. This is yet another piece I'll give you as soon as you join the bootcamp for people who want to join, right? And for people who are in the bootcamp, guys, use this important resource, right? Percents, exponents, rates, ratios, right? Each of these are so easy. You just need to do two problems per. Just click on it and do it. Just click on this thing. Just click on it over here, go over here and try to solve this problem. And right? Just solve this problem, and you should be just gonna close this over here. Just solve this. Very easy. Your understanding is going to improve massively. Okay, I've selected these problems and they help people a lot. Okay, so if you have difficulty, you can solve this, but email me if you have questions and I'll give you these drills. Okay, to solve. Okay, let's look at this problem here. So if you just read this, Jake buys a bag of popcorn. That's all you need. He buys a bag of popcorn and he's eating it. You don't even need to know how he's eating it. He's just eating, 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 eating. Okay, then he spilled some of it. Okay, you don't need to worry about what's going on. Okay, so now let's look at the graph of how his popcorn looks like. Okay, so the amount of popcorn he's got at the start, right? It's maybe he's got like a full bag or something, and then it keeps dropping, right? That's it. You don't even need to read anything. Sometimes I'm just trying to show you how easy the problems can be. Okay, sometimes they won't be as easy, but like these are the opportunities that you need to take, right? All right, so try this problem here. Okay, super easy to solve it. So try it just for a few seconds, at least like 15 seconds, and see which is the easiest, which one you get. Right, so it's easy to see, right, what's going on over here, right? The amount of popcorn in the bag, right? It's clearly like he's eating a popcorn, like the amount of popcorn only decreases and decreases and decreases with time, right? Exactly right, Franti. It only decreases. How can it increase? You'd be the richest man in the world if the popcorn starts increasing when you're eating it, right? So that that's why, right? And it, so if there's an increase, this means increase, right? So that's gone, right? That's why this is incorrect, right? There's this is a very good answer. Maybe this is right. It increased. Why did it? How can popcorn increase, right? So that's why this is gone. So the SAT is constantly trying to check if you can visually see these problems this way, right? Again, it increased. How can it increase? So this is gone, right? And that's why this is your answer without even looking, right? Of course, they're saying quite a few things over here, right? He eats half of the popcorn, so this is half, right? It went to half over here. Then he stops eating. So, okay, he stopped eating. Don't waste your time this way. Just look at the answers. And sometimes you can get the faster answer just this way, looking at it and getting the answer, right? In less than like 10 seconds. Okay. So remember, you've got 58 questions, right? Out of these 58 questions, I would think if you practice really well with me, 30 questions, you should be able to solve under 30 seconds. Just visually solve them because they keep repeating again and again, right? That means these problems you're able to solve in just 15 minutes. Okay, because every problem 30 seconds and 30 problems, so you can solve in 15 minutes. And then the rest of the problems, right, out of 28 problems, there will be 10 problems which are probably hard, and the 18 problems, they're kind of like you just need to work on them a bit more. But think about amount of time that you will have, right? 15 minutes. If you solve 30 problems in 15 minutes, that's like the ideal goal, right? If you can solve this, then you're really really good at getting a great score. Okay, so we've covered, just to summarize this, right? We covered this problem, let x equal to, remember that is an important problem. We did the linear equations problem, right? H is equal to something a plus 4, and this was 3.4 or something, and this is the increase, the unit rate. We're going to talk about this again very soon. Then you got the rates and ratios. Yeah, Stefania, get in touch with me and I'll let you know. Okay, Hamza, I'm still deciding if I should or should not, but I'll get in touch with you guys and tell you if you're going to do that test. But at least watch the other earlier videos that I've sent you, right? So you can try those ones. Um, okay, so we've done rates, we've done this, we've done this, we've done this, and then we've done percents as well. Okay, and exponential models. Okay. Oh, I forgot that one piece of the exponential model. I know we are pretty much done on time. Sorry about that. One thing I forgot to mention, so please bear with me for just a quick minute. Okay. So you've got 1,000 here. It goes up by 2%, 2%, 2%, 2%, 2%. That's easy. 1,000 times 1.02 to the teeth power, right? Or whatever, like 5 if it's 5 years. Now, it could also be such that it goes down. Okay. It goes down by, let's say, 3%. 3%, 3%, 3%. Okay, so here you're not, because you would take 1.02, here you're going to get 1 minus 0.03. Okay, and let's say this is like the population of a country, it's going down, right? So maybe the population is like 1 million or something. Okay, so you're going to have 1 million times 1 minus 0.03, right, to the third power, right? This is going 3 times. Okay, so this is the exponential decay model. Okay, this is like radioactive stuff, like populations of countries can happen, some bacterial kind of populations as well. Samples can decrease in size. Okay, money kind of mostly increases in price, stock market increases in price. Okay, same deal, they're like brother and sister over here. Okay, or almost like twins. Okay, so 1.02, 1 plus 0.02, 1 minus 0.03. Okay, very nice. People who got this answer, very good. Okay, so I think this is just the population decay. You'll see some problems here in the sheet that I'm going to send over. Where's the sheet? This one, where you'll see maybe 1 or 2 problems of the exponential decay type. Okay, exponential decay is super useful. So so they might ask you some problems. Okay, so there's tons of problems here. This is one of the, all right, here it is, one of the problems over here. Okay, exponential expansion. Okay, so all of these problems super important. Word problems is very important, guys. Watch this video again, and then I think you're gonna, this video alone, this session alone is one of the most important ones. So with that, we'll close the session, and we'll see definitely each other on Monday. I don't know if we're going to do a Sunday session, but for sure we're going to do one on Monday at 8:30, where we're going to talk about percents and exponents. Okay, so with that, we'll close the session, right? Work on the problems. I'm going to send them to you. For the new people who want to join the boot camp, just email me and I'll let you in. Remember, it's just $95 for a one-time fee of that much, and it's really worth it, right? Some people have gone into their dream college with it. So wish you the best, and I'll send you the recording in maybe an hour or so. Okay. So have a good night, enjoy yourself, and I'll see you very soon. All right. Bye.